All right, so we've seen previously that if we want to solve this system equation, if we want to find out what the x and the y value are that make both of them true, we could go through and graph them by solving or taking each equation, solving it for y to get into slope-intercept form, graph both equations, find out what the intersection point is, and that's the solution. But if you don't have graph paper, it kind of becomes a pain in the butt. It's not necessarily the quickest method. So what we're learning here is a new method called the substitution method. And if you just tried to come up with a solution, so we know the solution of here is an x-y pair, like 5, 3. You could check and, plug in a number and check to see if it works, but the chances of you randomly guessing and checking a solution that works for both equations is very slim. So here's how this works. The general rule of solving an equation is this. You can't solve an equation if there's more than one variable. You can't. You cannot find out what that variable is if there's more than one. So what we need to do is we need to get rid of one of the variables. We need to get it so there's an equation with one variable in it. And the substitution method says this. If you get one of your equations, so it's like y equals or x equals, if you get the equation with the variable solved, we're going to take this and we're going to plug that into our other equation. Here's how. So I'm going to take this, and this is going to become x plus 2 times something equals 11. Now, this y, instead of me putting a y in here, which we already know we don't want two different variables. But we know that y equals 3x plus 2. It says so right here. Y is 3x plus 2. So instead of me putting a y down, I could put 3x plus 2. That's true, right? Y is 3x plus 2. So instead of y, 3x plus 2. And look what I have now. I have an equation with one variable. So I can solve this. I can find out what that x is. That x might be equal to 8. And that's awesome. So let's do that. So let's distribute here. That would be 6x plus 4 equals x. So I distributed. I'm solving here. So I'm going to combine like terms. 7x plus 4 equals 11. Getting rid of this multiply is last, so getting rid of this add 4 is first. So I'm going to subtract 4 to cancel it out. 7x equals 7. Divide both sides by 7 and x equals 1. So we've found now that in our problem, our x value is 1. That 1 is a solution in both of my equations. So if I take 1 and I plug it into either of these equations, it will give me the exact same y value. I don't want to delete all this stuff yet, so I'm just going to move him off to the side. Delete that. All right, so I'm going to take the x value of 1 and I'm going to plug it into both equations. I want to show you that it gives you the exact same y value. So if I take and I plug 1 in here, 3 times 1 plus 2 equals y. Y equals, that's 3 plus 2 is 5. So we believe the y value is 5. The only way to be sure is if we plug that into the other equation as well. So I'm going to plug in 1 here for x. And let's play pretend we don't know what the y is yet. Equals 11. This blue stuff is still in my way. Group ye together. Missed a piece. Group, get it away. All right. And if I solve for y and I subtract 1, 2y equals 10. And look at that. Divide by 2, y still equals 5. We found a pair of numbers that makes both equations true. If I would check this and I would plug in the 1 and the 5, we know it's going to work here because 3 times 2 is 5. Yay! We probably know it's going to work here. Hopefully you have faith it's going to work. 1 plus 2 times 5. 2 times 5 is 10 plus 1 is 11. This is the solution. We did it by substituting in from one of our variables. You could not have an equation with 2 variables. You could only have an equation with 1. So we said this y is equal to, well, it's the same thing as that y. It's the same letter. So if y is equal to 3x plus 2, let's plug in a 3x plus 2 in for y. And when you plug in a 3x plus 2 in for y, like we did here, and we distribute, and you solve, and you solve, and you solve, we found an x value of 1. That x value of 1 works in both equations.